greater, if the y value is greater, then it's increasing, and if it's less, then it's decreasing.
Okay. And if you look at these parent functions up here that we did yesterday, can you give me an example of one of these parent functions that would be an increasing graph? So I heard linear. What else? Exponential is increasing. Anything else? Square root is increasing. Cubic is increasing, even though it does that little shimmy, right? It's still increasing. So, yeah. So you were able to just, in your own words, state what increasing and decreasing is. But let's try and make that mathematical language in the definition, let's try and make it make sense. So for increasing, it said, what did it say about the x1 and the x2? Oh, I just spelled that wrong.
X2 has to be greater than x1.
Okay. So it said, as x1 is less than x2, what did it say about the f of x? Yes. And then what do we know that f of x stands for? Function of x, but we also just use f of x in place of, can it just be the y? So this is saying that as x's increase, then the f of x's, or the y values, they also increase. And so you could draw a little picture of that, where you have this line that's increasing, but we're going to look at it in terms of from A to B. So we've got a starting point and we've got an ending point. Okay? Well, that first point has an x value that we're calling x1. The second point has an x value that we're calling x2. And so x1 is less than x2. We've got that drawn there. Perfect. And then f of x1 would be the y value for this first point. So that would be right here. And then the f of x2 is the y value of that second point. So we're going to put that right here. And is it true that f of x2 was greater than the f of x1? Yeah. Okay, so we've got that graph drawn. Then if we go to decreasing, the definition said x1 is less than x2, and then what did it say about the f of x? Yes, f of x1 is greater than f of x2. So this time, as the x's are increasing, the y values are decreasing. And if we drew a picture of that, you'd have something that looks like this. Forgive my not straight lines, goodness. And so if we're looking from the interval from A to B, our x1 would be here, but our f of x1 would be here. And then our x2 would be here, but our f of x2 is going to be less than f of x1. It's going to be down here. And so that's the definition of increasing and decreasing. If I go by that definition, if we take a solid point, so let's say this point right here, the first blue point, would we say that that's increasing or decreasing at that point? Based on the definition, can it be? Is the x1, like, is it going to be less than or greater than another point? Like, it's, like, we can't say that that specific point is increasing or decreasing. Just like if you look at the absolute value parent function that's up there on the board. At the turning point, that particular point is neither increasing or decreasing. But the intervals are, but a specific point is not. Okay, so you're going to, if you click next at the bottom of your pre-reading, it takes you to the exercise. And for the first exercise, first problem in the exercise, it says to take your parent functions that we did yesterday and write the increasing and decreasing intervals for those. Well, you may or may not know how to write the intervals. Let's do one with just a generic graph. So draw this in your notes. And now that you know the increasing and decreasing, how many sections of this graph are increasing? 2. Which sections? Left, right, middle, which ones? Left and the far right. So this one is increasing and this one is increasing, right? And then the decreasing section would be the middle. So if you think about it, like when you're looking at these, it's like you're walking on the graph from the left to the right. I'll draw my nice little stick figure. If I'm walking on this graph, I'm going up, then I'm going down, so that's decreasing, and then I'm going back up again. Okay, so that's how you look for increasing and decreasing. All right, so let's write what the intervals are. So we're going to have increasing intervals, and we have decreasing intervals. Okay, so when we write intervals, and we talked about this the other day, intervals they kind of look like ordered pairs, but an interval has a starting point and an end. Or if it doesn't end, then you'll use infinity, but bottom line, you're writing an interval as something, comma, something. And then we also talked about whether to use parentheses or brackets, right? And in domain and range, you can use parentheses or brackets. But for increasing and decreasing, again, we have to think about that point. Is that point right there increasing? That point right there, the stationary point, is that increasing? No. So we're always going to use parentheses because at that particular point, we can't say whether it's increasing or decreasing. By definition, we can't. So we're always using parentheses when we're looking at increasing and decreasing. The other thing you're always going to use is you're always using the domain values. Domain is what again? The x values. So we're only using the x values. So if I look at this graph, and I did a grid on purpose, I know you might have to squint your eyes to see what it is, but what is the domain values for this first interval that's increasing? I'll help you out. -3 to -3 to, where does it stop? What's that x value right there? 0. And we're going to put parentheses around it. Now again, that does not represent the point -3, 0. It's from -3 to 0. Okay? What's the other interval that's increasing? 2 to 4. So 2 to 4. And then anytime you have more than one interval, you're going to use this mathematical symbol in between it. It's a U. It stands for union. When in mathematical terms, that means or. So it's increasing on -3, 0 interval or 2 to 4 interval. Okay? All right, what would be the decreasing interval? 0 to 2. So that's how you write the interval notation for increasing and decreasing. Okay, so now you can do all of those parent functions. We'll give you some time in a minute, but let's look at number 2 and number 3 on the exercise. So number 2 and number 3 is using this function right here, negative times x minus 3 times x plus 3. Okay, now we need to know what the graph looks like in order to write down the increasing and decreasing intervals. What kind of parent function does this belong to? Why quadratic? The x's are going to square. Perfect. So when you go ahead and multiply this together. Everybody multiply this together and get it in standard notation. Standard form. Very good question. So do you have to do the negative first? Or can you do the x minus 3 times x plus 3 first? It honestly doesn't matter. You could do either one. But if you're going to multiply the negative through first, do you multiply it to both parentheses or just one? Just one. So it's up to you on how you want to do it. You can multiply the negative times the first one, then multiply, or you can do the parentheses first and then just distribute the negative through. Okay. Anybody want to share what they got? What'd you get, Arian?
I got y equals negative x squared minus 5.
I got me too. Plus 9.
So would it be minus 9 or plus 9? What do you think?
I got negative x squared plus 6x plus 9.
Okay.
Yeah.
Okay, so let's work this out. We got some differing opinions here. So let's start by just multiplying those parentheses together. So I'm going to put the negative on the outside. What is x minus 3 times x plus 3? So what would the first distribution give you? So it'd be x squared, then what? Plus 3x. And then here, well, we're not going to do the negative yet. We're going to wait to do the negative at the end.
But is it negative 3? Yeah. So if we're not distributing the 1 yet.
So I left the negative on the outside here. I have not done it yet.
No, but there's a minus 3
times x.
Oh, yeah, I haven't done that yet. So, but I did this one. This one is 3x. Then I'm going to do this one. That's negative 3x. And then this one. Got it? So does the 3x and the minus 3x give us 6x? No, it does not. It cancels. So then, because I just hadn't written it down yet. So what should that last number be? It should be a positive 9. Okay. Did you find what you did wrong or no? No?
Because we did the negative before we did
Okay, so if you did the negative first, you would have had negative x plus 3 that's going to get multiplied by an x plus 3, right? So you have negative x squared. Then you'd have a minus 3x. But then you'd have a positive 3x. And then you'd have a positive 9. Do you still get what I got? Okay, you found it? Okay, perfect. That's okay. It's all right. It happens. Okay, so here's our function right here. And you're right, it is a quadratic. So quadratic means it opens up or down. It could be either. So quadratic is going to be a parabola. It could look like this or it could look like this. Which one do you think this function is going to look like? Is it going to open up or down? Down. Why? Because the negative x squared. So this part right here tells us that we have a parabola that is opening down. Okay? So we have a general look at the picture, right? Girls, y'all are like, your brain is fried at the end of the day on a Friday, aren't you? Yeah, you're having a hard time. I know, it's Friday, it's tough. All right, so here we've got this parabola, but we've got to be able to figure, does it have an increasing and decreasing section? Yes. But now we need to figure out what this top point is because we've got to write it as an interval. What do you think that top point's going to be? 0 what? Just 0? 0, 9? You think it's 0, 9? Let's test it. So you're saying that this might be 0, 9. Do we? Is it? You think? Let's try it. Let's build a table. Wait, what? You think it's not? Let's see. So if that was our top point, let's put that one in the middle. So let's put a 0 for x, which would then give us 9 when we plug it in. So 0, 9, we're going to put that in the middle. What would be 2x values before 0? Negative 1, negative 2. What would be 2x values after 0? 1 and 2. Okay, so let's substitute those in and see what happens. Let's start with the negative 1. So we would have negative, then negative 1 squared plus 9.
Should we write this part?
Yeah. So what would that be? You think it's 10? Wait, what? So I'm plugging in negative 1 right there. What do I do first? Do I do the negative or do I do the squared? Order of operations. Do you do exponents or do you do multiplication first? Exponents. Exponents. Okay, so negative 1 squared is what? 1. Then you've got to make it negative. So negative 1. So it'd be 8. You got it. So, again, negative 1 squared is 1. And then 1 times negative 1 is negative 1. And then negative 1 plus 9 is 8. What would we get if we plug in positive 1?
5. Wait.
Yeah, you did negative 2. What would we get if we plug in positive 1?
10.
10?
9. No. 8. 11. No.
Just going to keep going down till you get it. It would also be negative 8, because isn't 1 squared the same thing as negative 1 squared? So this would also be 8. It's looking like that might be my top point, isn't it? Maybe? Okay, let's plug in negative 2. Negative times negative 2 squared plus 9. Y'all, lock it in. We got just a few more minutes. Negative 2 squared is 4. Make it a negative. And then plus 9 is, yeah, so you got it. Would the 2 also be 5?
Yeah.
Okay. So it looks like that 0, 9 is our top point, isn't it? Because the other points would just be on either side of it, but down here, right? Okay, so let's get back. Let's focus back. We're writing the increasing intervals, and we're going to write the decreasing interval. We had to do all that work so that we could now decide what our increasing and decreasing intervals are. So just because I put on my table, I started at negative 2, does that mean that's the lowest it can go? Yeah, it can go to infinity, right? Is it positive infinity or negative? Yes. So look, here's your graph. If I'm looking at those x values that are all the way over on that left side, that's going to keep going forever, but it's going in the negative infinity direction, right? So this goes from negative infinity to that interval goes from negative infinity to 0. Good. Negative infinity to 0. And we're going to put parentheses around both. What's the decreasing interval going to be then? 0 to infinity.
Positive.
Yeah, you got it. Good job. Woohoo. Okay, so you should be able to finish that exercise now. You want to do the parent functions around the room. Get those in your journal, and now also write what intervals are increasing and decreasing. And then you should just finish out the exercise. You don't have a whole lot left to do on the exercise because we did this part together. Okay, the other thing that you need to make sure you get done this